and here is limit x goes to 1 minus. We are going to apply, we are going to differentiate it, right? We are going to differentiate the top and bottom separately. So upstairs, x1, 0 minus 1 over x. And down here, ln x times x minus 1. So when you differentiate that, what do you need? Yes, you do need the product rule. So I'm going to differentiate this one first, okay? So 1 over x times x minus 1 plus, here is ln x, and the derivative over here is 1. Correct? Okay? So now we have kind of ugly, it's 1 minus 1 over x. We have a complex fraction over here. So how do we overcome this one very quickly? We are going to multiply top and bottom by x. So x over x in short. Multiply by x over x. By doing this, okay, by doing this, this one is x. By doing this, this one is going to be just 1. So what do we have? Here is a limit. X goes to 1 minus. This part is x minus 1. What about this part? X will cancel this 1 over x over here. So this is, it already used, so x minus 1. The next one is, we have to multiply, distribute over here also. So plus x times ln x. Okay. So now what do we have? What do we have over here is, this one is 0. The numerator goes to 0. And what about here? This is 0. And the ln, this is 0. What about ln 1? That is again 0. So 0 over 0. Oops, we have to use L'Hopital's rule one more time. Okay? So here we go. I'm going to erase this. Okay. Second time around, we are going to apply L'Hopital's rule again. So what is going on? Limit x goes to 1 minus. This time x minus 1, so 1. Oh, as I see 1, I have a feeling like I see the light end of the tunnel, okay? X minus 1, so the derivative is 1 again. This one apply the product rule, so 1 times ln x plus x times 1 over x, which is 1, okay? Which is 1 here. So what do we have? This is 1. This is ln 1 is 0. This is 1. So now I see the light. 1 over 1 plus 1, which is 2. So the final answer is 1/2. Okay? 1/2. So what can we say? This infinity minus infinity is kind of really neck and neck. We cannot say that nothing is, neither one dominates. So that's why we have like a, it's a pretty finite, just the definitive answer over here. Okay? Okay. Well, we studied a lot, and now let's summarize over here. We talked about indeterminate form. So indeterminate form. Here is 0 over 0, infinity over infinity, 0 times infinity, 1 to the infinity, which one? Again, 0 to the infinity, and infinity minus infinity. How many is that? 1, 2, 3, 4, 5, 6. Is there another thing? Let me see. 1 to the infinity. Oh, 0 to the 0 power. Yeah, I'm sorry. 0 to the 0 power. Because 0 to the infinity, oh, this is absolutely 0. Okay? 1, 2, 3, 4, 5, 6, 7. Infinity to the 0 power. These are indeterminate form. What about just, this is not indeterminate, so this is a determinate form. Needless to say that, well, what about infinity plus infinity? That's absolutely infinity, okay? What about infinity times infinity? Of course infinity. What about 1 over infinity? Oh, this is just 0, okay? What else we can say? Any type that, yeah, infinity times this, yes. Just when you see these things, you do not apply L'Hopital's rule, okay? I want to mention that those homework problems, by the way, in terms of homework problems, I assigned the homework problems on WebAssign. I picked 15 problems, okay, 15 problems from this section 5.6. This is due Friday night. Well, Friday night, why not Thursday? Because yeah, this is a new thing, and I'm sure everybody is a little bit stressed out about the situation, and we are changing to from the online classes and stuff. So I'm sure it's a lot of going on around here. So I'm going to give you a little more time. On the other hand, I assigned the homework to get ready for the quiz on Thursday. Yeah, life goes on. Whether we have whatever we have here, we are going to take probably quiz 9. Okay, quiz 9 is going to cover trig substitution and partial fraction. Probably I'm going to ask 4 problems in the quiz, okay, and so I just assigned 4 problems in the homework as well, okay. So you practice those problems, who knows, well, you will be ready for the quiz. All right, quiz is going to be, of course, on WebAssign, and I'm going to give you some designated time, and we are going to work on that. I was thinking about Thursday morning, 8 o'clock, but well, it can be a little logistically, 8 o'clock could be a little early, so maybe 9 o'clock, okay? You can start quiz at 9 o'clock, and that I'm going to set like that way. If I change my mind or I change my plan, I'm going to let you know. But changing my mind means changing the time, okay? Because some of you work, but I chose 9 o'clock because you are supposed to be in my class at 9 o'clock, right? So not as early as like 8 o'clock, but still you are supposed to be in my class. So that's why I chose 9. Okay? Well, we are finishing at 9:40, so 9 o'clock could be very reasonable time. Okay. Once I set it up, I will email you again. Okay. I'm going to look at some problems over here, and I'm going to just keep going as the book writes, and then you tell me, oh, that's not true, okay? Excuse me. Limit x goes to 0, e to the 2x minus 1 over e to the x. Oh, kind of an exponential function, so just, okay, I'm going to apply L'Hopital's rule. So limit x goes to 0. So I just differentiated, so e to the x. And the e to the x, the derivative e to the 2x, so 2 times e to the 2x. at this point, oh, I can cancel, correct? Okay, limit x goes to 0 and e to the x 2 times e to the 2x means what? E to the x times e to the x, isn't that right? So e to the x is cancelled. So I'm going to say, oh, e to the 0 is 1, so 2 times 1 equals 2. So answer is 2. Tell me which part is, if everything is alright, or at some place I made a mistake. What do you think? Yes. The first portion over here, I thought I was able to apply the L'Hopital's rule, but it's not true, okay? It's not true over here, because look at this. E to the 0 is 1 minus 1 over e to the 0 is 1. So therefore this is 0 over 1 case. 0 over 1, 0 over 1, therefore answer is 0. So this is, we can determine the limit as is. It does not require L'Hopital's rule, and yeah, more accurately I have to say that we cannot apply L'Hopital's rule. Okay? So do not just apply, just use L'Hopital's rule just anytime you feel like you have a little just issue, then you use it. Don't do that. Okay? What about limit x goes to infinity, x times cosine 1 over x. What do you think? Can you apply the L'Hopital's rule? Okay. Well, earlier when you have an indeterminate form, this is a product. Only one product is the problem, I mean indeterminate form, which is 0 times infinity. So let's see what happens. X goes to infinity, yes, so this one goes to infinity. What about over here? Cosine 1 over x. 1 over infinity is 0, so cosine 0 is 1. So it's not indeterminate form. It is infinity times 1, therefore answer is infinity. Okay? So do not rush to jump on this L'Hopital's rule stuff. So you have to evaluate each one carefully, and then, yes, whether you decide whether you are going to apply L'Hopital's rule or not. Okay? Well, in order to do that, you must know all these trigger function values very well. Alright? The trigger function values and the exponential function you have to feel comfortable with, and the logarithmic function. Okay? Is there anything we can do? Oh, by the way, I'm going to go back to Calculus 1 class. Okay. In Calculus 1 class, you are asked problems like this. Limit of x goes to, so let's say, goes to 6, square root of x plus 10 minus 4 over x minus 6. At that time, this L'Hopital's rule was not known to you, so what do you see? That's not an option, okay? So as you plug in, x goes to 6, so square root of 16 goes to 4, so 4 minus 4 over 6 minus 6, which is a 0 over 0 form, is an indeterminate form. In Calculus 1 class, the way you learned is, hey, we are going to overcome this within algebra area, okay? This algebra area meaning we are going to rationalize this. Okay. So we rationalize it, that means we are going to apply square root of x plus 10, the conjugate, plus 4. Apply the same thing, or multiply the same thing, plus 4. Okay, what happens over here? as you multiply, as you FOIL this, okay, what you have over here is a limit x goes to 6. Okay, I do not like this black. Limit x goes to 6. So here is x plus 10. As you multiply this and this, minus 4 and 4, so 16. And what about denominator? Denominator is x minus 6. And here is, there's nothing you can do. It's the square root of x plus 10 plus 4. What happens? Here is x minus 6. Okay? This one is indeed x minus 6. Therefore, x minus 6 cancels. So, as a result, we have a limit x goes to 6. Here is 1 over square root of x plus 10 plus 4. So again, plug in x equals 6. Square root of 16 is 4. So 1 over 4 plus 4, which is 1 over 8. This is how we solved this limit problem in calculus 1. Okay. Now, in calculus 2, yes. Earlier we verified that this one is 0 over 0 indeterminate form, so we are going to apply the L'Hopital's rule, okay? In the homework, they are going to ask you in both ways. Solve this one with the technique from chapter 2 or something, and solve this problem with the L'Hopital's rule, okay? X goes to 6. The derivative of this guy, yes, that is like a square root of x. Even if we apply chain rule, it doesn't change much. So 1 over 2 square root of x plus 10. Derivative of x minus 6 is 1. So what's going to happen? Yes, this is L'Hopital's rule. So limit x goes to 6. This one comes in denominator, so 2 times square root of x plus 10, 1 over. So now what? 6 goes in here, so square root of 16, which is 4, 2 times 4, so 1 over 2 times 4, which is 1 over 8. Yeah, I remember we did earlier that the answer was 1 over 8. Okay, so 2 different ideas. We got the same answer, 1 over 8. Which one do you like better? Yeah, I think this L'Hopital's rule is a little easier. Well, I'm not saying that, the rationalization is difficult, but, it's not very likable one. I have to admit that, okay? It's not very likable one, but this one is very good one. So, when you do homework, you are going to show certain problems in both ways. Yes, this one is going to be one of the ones. Okay. Just one more and let's finish. And apply this idea of limit x goes to 0, sine 6x over 4x. Because as x goes to 0, this is 0 over 0 form. Okay, so what is that? We can use L'Hopital's rule. Therefore, we can differentiate the numerator and denominator separately, which is 4. Always I do easy one first. Derivative of a sine function is a cosine, so cosine 6x, but the chain rule will bring 6 out here. Okay? So now we calculate this limit. X goes to 0. So 6x goes to 0. So sine 0 is 1. Therefore, answer is 6 over 4, or you reduce it to 3/2. So this is how you calculate those limit problems using L'Hopital's rule. Okay? So 1 minute for the So how we are going to use L'Hopital's rule? The next section is about improper integration. Improper. Well, what makes this integral improper? The one very typical case is this. Yeah, one time I showed in class also here. You want to integrate this, integrate from negative 1 to 2, 1 over x dx. Looks very innocent, looks okay, but it is not okay because in order to integrate the function has to be continuous. As you see, this continuity over here. Okay? So how we are going to solve this one problem? We are going to split this one into two parts of an integral, and we are going to use the limit concept. Okay? Another thing is like over here, let's say from 1 to infinity. Wow, 1 to infinity? Are we using infinity for definite integral? Definite integral means we are going to have some finite numbers over here. Okay? So we cannot allow infinity in the definite integral. So that's why we call it improper integral. Then we are going to again use the idea of a limit. So for example, we are going to change it to 1 to a, 1 over x dx, and then limit this a goes to infinity. Sometimes in order to settle this kind of integration, we may need L'Hopital's rule. That's why we learned L'Hopital's rule right before improper integrals. Okay? And in terms of resources, by using WebAssign, we have a lot of resources. Okay? As you enroll, okay, so far I saw like 5 people. Okay? I even remember the names. Yeah. And I'm sure all of you are going to be on the on the roll, and as you go the login and not just looking at just my homework assignment. Other than that, there is a resources in the bottom of the page, and you click it and you are going to see a lot of videotapes over there. Okay, so important concepts or important problems and examples are solved very, very nicely. So use all kinds of resources. Well, they offer it for free. So yeah, they regard me as like a future client, right? Okay, so I like it so far. So I think this is a good thing for us. So let's enjoy and take advantage of this opportunity. Okay, bye and see you next time.